Let's look at solving polynomial inequalities. Here is a polynomial inequality. You notice it has a less than or a greater than symbol instead of an equal symbol. This one's already factored. What's going on here? Well, if we graph y equals x plus 5 times x minus 2, you notice that some of the graph is above 0 and some of the graph is below 0. And of course, it's at 0 twice. So where the graph is below 0, well, that's less than 0. Well, where does that seem to happen? Looks like it happens between negative 5 and 2. When x is between negative 5 and 2, this graph is below 0. When it's not between negative 5 and 2, it isn't below 0. So that would be the solution to this polynomial inequality. But we're not going to graph everything. We need to see how we can do this using algebra, and we'll do it with sine graphs. Let's see if we get the same answer. Step 1 is to get all the non-zero terms on the left side and 0 on the right-hand side. You really do want to have 0 on the right. Well, that's already done for us in this problem. Step 2 is to factor the left side completely. And once again, that step is already done. Now think about if we're looking for less than 0, equal to 0, and or greater than 0. There's 3 possibilities that you can be compared to 0. We just have this less than 0 symbol. So let's look at less than 0, equal to 0, or greater than 0. We are definitely looking for less than 0. That'll make us happy. We are not concerned about where x is 0. If we were, there would be a bar underneath this inequality symbol. And we don't care about where x is greater than 0. That would be a positive if you're greater than 0, but this is less than 0. So in the end, the only one we're going to really care about are the negative signs. You'll see what that means in a moment. Let's create a sine graph. So I've got a number line, and I leave plenty of space above and below. Be sure you leave a lot of space above. We're going to take each factor and put an open or closed circle to represent 0 on the graph above the main number line, and we'll put negative symbols to the left and positive symbols to the right. Let's start with the factor x plus 5. If you set x plus 5 equal to 0, you get that x equals negative 5. That means when you plug in negative 5 in for x, you get exactly 0. So I put a open circle or an open 0 there. It's open because this is a less than symbol. If this was less than or equal to, I would have used a filled in 0. Anything to the right of this is going to get a plus sign. If you stick in negative 4 for x, negative 4 plus 5 is positive 1. If you plug in 1 for x, 1 plus 5 is positive 6. Any number you plug into the right is going to turn the value of x plus 5 positive. If you plug in any of these values to the left, you'll get a negative number. For instance, plugging in negative 6 plus 5 is negative 1. That's a negative number. So once again, find out what makes that factor 0. Put a 0 there, either open or close, whatever is appropriate to the problem. Everything to the right gets a plus sign. Everything to the left gets a negative sign. We'll do the same thing with x minus 2. When x is 2, 2 minus 2 is 0. So I have an open 0 at 2. Everything to the right gets a plus sign because all those values make x minus 2 positive. Anything to the left gets a negative sign because any of these values, when you plug them in for x, even positive 1, 1 minus 2 is negative 1. They give us negative answers. So that's our first step, is to, for each factor, put in the zeros and then go plus symbols to the right, negative symbols to the left. Now we're going to multiply vertically. I like to start with a 0. 0 times anything is 0. So 0 times this negative symbol is 0. 0 times this positive symbol is also 0. Now, a negative times a negative is positive. These are all negative times negative, so they're all positives down here. In this section, a positive times a negative is negative. All of these are positive times negatives, giving us negative results. And finally, to the far right, a positive times a positive is positive. So all of these get positive signs down here. So now we have a graph going underneath the number line. Look back at step 3 to remember what we need and transfer it to the main number line. You'll recall the only thing we really care about are the negative symbols. So we need to take these negative signs and move them up to the graph, and we'll have open circles at our 0 spots, which are negative 5 and 2. So we're going to slide this section up, and there it is. What makes this true is in between negative 5 and 2, not including negative 5 and 2. And we need to write this answer algebraically. This is a conjunction sandwich. So x is between -5 and 2, which is what we noticed on the graph a couple of minutes ago when we first took a look at this. Alright, pause the video and you try to solve this. You may want to go backwards in the video to review what we've already done. See if you can find the solution to x squared is greater than or equal to -6x following the steps we've already looked at. Now that you've tried this, let's quickly go over how to solve. Step 1 is to get all the non-zero terms on the left and 0 on the right. So we have to add 6x to both sides. Next, factor the left side completely. We always check for the greatest common factor first, and that's x. So we have two factors, x and x plus 6. Are we looking for less than 0, equal to 0, and or greater than 0? Well, we don't want less than 0. We do want equal to 0, and we want greater than 0. So we care about the zeros that are filled in and the plus signs. That's what we ultimately want. Here's the sign graph that you hopefully created. Set x equal to 0, well that just is 0. Everything to the right gets a plus sign, everything to the left gets a negative sign. X plus 6 equals 0, that happens when x is -6. So again, I put a 0, it's filled in. Both of these got filled in because I have a or equal to symbol here. Everything to the right of this gets a plus sign, everything to the left gets a negative sign. When we multiply vertically, 0 times anything is 0. Here's a 0 times a plus sign, it's 0. A negative times a negative is positive. A positive times a negative is negative. That's this whole section. And over here, a positive times a positive is positive. We have to remember what we saw in step 3. What ones do we really care about? And if you'll recall, we need the green plus symbols and the purple filled in zeros. We're going to take these sections and slide them up onto the main number line. And there they are. Move this part up, move this part up. It's a disjunction. It's shooting off in two different directions. And again, we have filled in circles, so we'll have to use or equal to. It looks like this is good when x is less than or equal to -6, or when x is greater than or equal to 0. So that's what we'll write for our answer.